Good morning, all. In the last session, we have discussed about the principles in material handling system, uh, what type of care should be taken while designing a material handling system that we have discussed. So, in this session, we will discuss about material transport system. That means the systems that are used to transfer the material. It can be manually controlled or it can be automatically controlled. Okay, so based on the purpose, need, requirement of the plant, uh, then the conditions in the plant, based on that, the different transport systems are chosen, and basically nowadays these are selected based on the application. That means what is the application, what is the type of material, how much is the distance, what is the accuracy needed, what is the flow rate of the material, depending upon so many parameters. The type of transport system that needs to be selected are there. So we can see which equipments are there and what are the applications. So industrial trucks, it is manually driven. It has a low cost, low rate of deliveries. Obviously, there is human interference. Then applications moving light loads in factory. It should be loads moving light loads in factory. I'll make a change. Moving light loads in the factory. Then industrial trucks which are powered, uh, medium cost, moving pallet loads and containers. Then automated automated guided vehicles, vehicle systems. So features means it's costly. It is obviously battery driven, battery powered. Then flexible routing can be done. Non-obstructive pathways. Uh, then applications moving pallet loads and work in process along variable routes in low and medium production. Monorails and other rail guided vehicles, that is it needs high cost of installation. Then flexible routing on the floor or overhead types. Uh, Moving single assemblies, products or pallet loads along variable routes and large quantities of items over fixed routes. Then conveyors, power, in floor, on the floor or overhead load, moving or sorting products along the manual assembly lines. Cranes and hoists, lift capacities ranging up to more than 100 tons, moving large heavy trains in factories, mills and warehouses, etc. So we'll see how this industrial trucks, AGVs, monorails look like in the coming slides. So in case of industrial trucks, you will be having information regarding hand trucks, uh, four-wheel dolly, low lift, pallet truck, walkie trucks, forklift, rider trucks, towing tractors. In case of AGVs, you will see driverless things, pallet trucks, unit load carriers. So these are some examples of this. These are industrial trucks. These are non-powered. Okay. and these are forward trucks. So here you can see hand trucks, four-wheel dolly, second one, this four-wheel dolly. This is hand-operated loaded pallet truck. This is the pallet on which load will be taken. Then here you can see uh, forward trucks. This is a tow tractor. There, there is a trailer. Uh, this is a tractor or this is a truck. It is having a forklift, so it can be driven from here. One person will drive this truck, and this is a simple walkie truck. That is, it should be it is manually driven. Person will walk along this walkie truck. Okay. Now these are automated guided vehicles. These are driverless. They will automatically check the path or sense the path and will go along the path. Okay, that means there can be white lines or there can be lines which are marked by radium and the vehicles will be guided over that track, that path, which is initially defined. So there won't be any mistake or there won't be any problem of missing the location. These vehicles will simply follow the path. Uh, you can see the sensors are there in front of that vehicle. This, this is one sensor, this is another sensor. They will have the front area. That means this one sensor will check the presence of the white line for this much region. Okay. The same way, uh, two sensors will be there. Normally, two sensors will be there in front of the vehicle or on the bumper. So they will sense the track. Basically, this module will give some overview for the different storage systems, different transport systems, automated storage systems, automated retrieval systems. So you can see here there will be a guide wire for this automated guided vehicle, electromagnetic field uh, will be there, and a coil when moving from this path, it will go along the wire, okay, guided wire. So simply it will shape the magnetic field along the guide wire and will follow the path defined by guided wire. Then monorails and other guided vehicles. This is the vehicles or the monorail will be motorized and there will be fixed rails. It will consist of one or two parallel rails, one rail or two parallel rails. Monorail in factories and warehouses are typically suspended overhead from the ceiling, and that will help us to save the uh, shop floor area. And in case of rail guided vehicle systems using parallel fixed rails, the tracks generally protrude up from the floor. Uh, Routing variations are possible in rail guided vehicle systems through the use of switches, turntables, and other specialized track sections. This permits different loads to travel different routes, similar to AGVs. Rail guided systems are generally considered to be more versatile than conveyor systems, but less versatile than automated guided vehicle systems. And this is and in case of one of the original applications of non-powered monorail was in meat processing industry before 19th century. Now we'll see about conveyors. Uh, there will be totally there will be normally two type of categories are there, that is powered and non-powered. In powered conveyors, the power mechanism is contained in the fixed path using chain or belts or rotating rolls or other devices to propel loads along the path. And powered conveyors are commonly used in automated material transport systems, in manufacturing plants, in warehouses, in distribution centers. In case of non-powered conveyors, materials are moved either manually by human workers or the operators who push the load along a fixed path, or it will go or it will move due to gravity from one level to the another level. Uh, Normally, these are the few types of conveyors that are used in case of uh, material transport system. First is roller conveyor, skate wheel conveyor, belt conveyor, chain conveyor, flat conveyor, in-floor tow line conveyors, overhead trolley conveyor, power and free overhead trolley conveyors. If you the details of this different types in short is given in the material. You can go through the details. Then cranes and hoists. Uh, Cranes are used for horizontal movement of material in the facility, and hoists are used for vertical lifting. That is a basic difference in between cranes and hoists. Crane invariably includes hoist. Thus, the hoist component of the crane lifts the load, and crane transports the load horizontally to the desired destination. So cranes and hoist means it's a one unit where you will find a crane and you will find the hoist. Okay. So this capable this class of material lifting equipments will have or will carry a load, or it will move a load around over 100 tons. So that is a huge capacity of this systems. It is normally used to move big machinery, containers, and so many things which are having uh, weight around over 100 tons, or near about 100 tons. You can see uh, this is a roller conveyor, skate wheel conveyor, and this is a belt conveyor. This is the in-floor tow line conveyor, and this is the overhead trolley conveyor. Carton track conveyor, and this is general arrangement for the conveyor, that is in one direction. On in another case, return loop is there. So for loading and unloading stations will be there, and between those stations the material will be transferred. Here you can see types of cranes. That is a breech crane and gantry crane. Then in case of assembly line automation, you will find normally two types of assembly line automation. Broadly, they are categorized into two, that is manual assembly lines and automated assembly lines. In case of manual assembly lines, you will find the workers are performing or doing the assembly, or they are arranging the components as per the design. They are just connecting the components. They are just or you will simply see in case of food industries, on the conveyor, uh, on the conveyor lines, the workers are arranging the small packs into one box. Number of packs will be there, and the workers will check whether the packs are perfect or not, or whether the material or the product is packed very well or not, and they will just sort out the or they will just sort the faulty packets, and that will help to pack the correct packets into the box. So two purposes will get satisfied: the packing insert, keeping the packets in the box, that is a one task, and second task is checking the or sorting out the faulty packets. Okay, so two tasks will be performed simultaneously. uh, so for that case, the workers are used in the assembly lines. In case of automated assembly lines, there won't be any attending person or worker. Uh, the components or the products will come from one side, and those will be checked by the sensors in the part, and accordingly the action will be taken based on the decision, which is coming from the controller after checking the feedbacks of the sensors. So there the time required for uh, getting the perfect or finished perfectly finished products will be that means the time required will be lesser as compared to the manually controlled lines, assembly lines. So that will be the advantage of using automated assembly lines. The time will be the time required for the processes will be lesser, but the initial cost of the setup will be greater in case of automated assembly lines. But that will also increase the production rate or overall uh, it will the system will can have the capacity to produce large capacity uh, in the shorter duration. Then conventional, we'll discuss about automated storage systems. So in case of conventional storage systems, we'll find the bulk storage normally done on the floor. Then the rack systems, shelving and bins and drawer storage. This we have discussed in the last session also about rack systems and all, or storage systems in short. In case of automated storage and retrieval system, carousel storage system is normally used. We'll see the things in short. We'll see the images, how the bulk storage is done on the floor. That means such big, or you can say one order is there, number of packets are there, number of boxes are there in one at one location. They are placed on the floor and they are arranged in stacks. Okay, this is another order or another quantity of the material. This is third one. So they are kept in bulk on the floor of the warehouse. Then this is a pallet rack system for storing number of units on the pallet, and whenever required, they can be taken out easily. There won't be any problem in case of removing or in case of taking one pallet from the stack system. Then these are the this is a drawer storage, simple drawers for the table. In that way, we can store the delicate or costly or the tools, hardware, etc. in the drawer. So every system has a different advantage. In case of drawer, small tools, stock items, repair parts can be stored, but it has a relatively high cost, but the contents of the drawer are easily visible. In case of bulk storage, the high density is possible, but the parts or the components are not accessible, but it will have a lowest possible cost per unit area. And normal application storage of low turnover, large stock, large unit loads. In case of rack systems, it will have a low cost, good storage density, and good accessibility is there. Uh, palletized applications, palletized loads in warehouses, shelves and beams. Some stock items are not clearly visible, and applications, storage of individual items on shelves, and storage of commodity items in bins. Then in case of automated storage systems, the advantages are high throughput rates. Disadvantages are high throughput rates, but it facilitates use of computerized inventory control system, so it will be easy for maintaining a record. Uh, Obviously, highest cost equipment are there. It facilitates interface to automated material handling systems. Uh, Normally, this is used for work in process storage systems, final product warehousing and distribution center, then order picking, uh, kitting of parts for electronic assembly. In case of automated storage and retrieval system, it can be defined as a storage system that performs storage and retrieval operations with a speed and accuracy under a defined degree of automation. The objectives of automating storage operations are normally to increase storage capacity, to increase storage density, to recover factory floor space presently used for storing work in process, to improve security and reduce pilferage, to reduce labor cost and or increase labor productivity in storage operations, to improve safety in the storage function, to improve control over inventories, to improve stock rotation, to improve customer service, and to increase throughput. So these are the objectives of the ASRS, that is automated storage or retrieval system. Uh, there are different types of ASRS, that are unit load ASRS, deep lane ASRS, mini load ASRS, man on board ASRS, automated item retrieval system, vertical lift storage modules, work in process storage, and this work in process includes buffer storage and production, support of just-in-time delivery, kitting of parts for assembly, and compatible with automatic identification system, uh, computer control and tracking of materials, support of factory-wide automation. This storage structure, it will be a simple rack framework, and it will be made up of fabricated steel that will support the loads uh, contained in ASRS. So it's a simple system. It's not having much complex structure. We'll see the images of that. You can see a unit load automated storage retrieval system. You can see the peak and deposit station here. Also, you can see the storage and retrieval machine. This is a vertical bar or rod, and this is one pallet type structure that will be used to retrieve or store the unit load. Then we'll see carousel type storage system that is used in case of automated storage system. This is a conveyor line, and this is a oval type horizontal storage carousel. You can see here drive motor system is there that will just rotate this carousel along this track provided by the structure, and these are the beams for inventory. The material will be placed by using this loading and unloading station, okay, at this location only, and whenever its work is over, this carousel will rotate, okay, and next section will come in front of that loading and unloading station. So this is how it will work. Now let's see about automated assembly systems. Uh, some system configurations you'll see here. These are the different ways of or the plans of assembly systems. You can see inline assembly machine in the first figure, A figure. Then dial type assembly machine in B. Then carousel type assembly system. Then single station assembly machine. So these are the general layouts for the assembly systems, and this will involve different parts. So workstation accomplishes one or both one or two tasks. That is, a part will be delivered to the assembly workhead and added to the existing base part in front of the workhead. That is the first one. And a fastening or joining operation is performed at the station, in which parts added at the workstation or at the previous workstations are permanently attached to the existing base part. In the part delivery system will have some parts, that is the hopper. The use of the hopper means the component that are loaded at the workstation. A separate hopper is used for each component type. The components are usually loaded into the hopper in bulk. This means that the parts are initially or randomly oriented in the hopper. Then parts feeder. Now this is a mechanism that removes the components from the hopper one at a time for delivery to the assembly workhead. The hopper and parts feeder are often combined into one operating mechanism. A vibratory bowl feeder that is shown in this figure, that is very common example of hopper feeder combination. Then next is selector and or orienter. These elements of delivery system establish the proper orientation of the components for the assembly workhead, and it's a device that acts as a filter, or it will consider the part, or it will take the part in the right orientation to pass through. Incorrectly oriented parts are rejected back into the hopper. Incorrectly means those which are not correctly oriented, those parts will be sent back into the hopper. So this orienter is a device that allows properly oriented parts to pass through. Several selector and orienter schemes you'll see here. These are the first is shown, that is a selector. Here the part will enter from the hopper, and here from here it will come out. It will go to feed track, and this is the orienter device that is used with parts feeders in automated assembly systems. So from here, this direction, the parts will enter into this enter from the hopper. It will come here. If some portion is coming over this or passing over this, that will be rotated because of the elevation, and the part will be like this. Okay, then it will go to the feed track. So that is how they are selected properly, and they are oriented properly. Uh, Few examples we'll see here. This is a rotary index table where the parts are taken, and there will be a horizontal delivery of those parts. This is a feed track, and when the parts come exactly in front of that delivery station, it will move like this. Okay, and sorry, whenever this uh, vacant position comes in front of it, The feed track will feed the component at this position, and then it will rotate like this. Then this is the vertical delivery station. So these are the this is the stack of the components and pockets in the rotary index table are like this. So whenever it is rotating, the index table is rotating. This these parts will come into the slot and they will be separated that way. Such application we have discussed in case of a pneumatic system uh, uh, in the introductory lecture, or after designing the different circuits for different applications. ते लास्ट जर तुम्हाला आठवत असतील त्याच्यामध्ये असे स्टॅक टाईप होते, मेजरिंग होतं, कटिंगसाठी होता, किंवा असे डिफरंट फर्स्ट कम फर्स्ट सर्व बेसिसवर स्टॅकमधून पार्ट्स रिमूव्ह करणं हा एक होता. सो नंबर ऑफ ॲप्लिकेशन्स वेअर देअर. Then spring blade escapement is there. So this is a feed track and these are the parts. Then this is a work carrier. So whenever this feed track is coming here, so it will be this spring blade escapement will just uh, provide the parts in this work carriers. Okay. This is a pick and place unit. This is feeder. So it will move like this. That means the pick and place unit will just reciprocate like this. It will pick the component, it will place at this position, okay, over here, and this work carrier will just move from this position to next position. So these are few examples of automatic systems. आता हे pick and place आपण सर्व बघितलंय. काही व्हिडिओज मी शेअर केल्या होत्या तुमच्या ग्रुपवर ॲप्लिकेशन्सच्या, ज्याच्यामध्ये तुम्ही काही ॲप्लिकेशन्स बघितली असेल, जस्ट लाईक असेंब्ली ऑफ दी बॉल बेरिंग और अल्ट्रासोनिक वेल्डिंग ऑफ द बॉल्स. सो अशा काही एक्झाम्पल्समध्ये तुम्ही न्यूमॅटिक इलेक्ट्रोन्यूमॅटिक सिस्टम्स पी एल सी सिस्टम्स ऑब्झर्व केल्या असतील. सो दॅट इज हाऊ वी कॅन automate the process. Here you can see the hopper where the parts are placed in the hopper, and that will come over here. This will be a selector and this will be a feed track, and escapement will be to this. So assembly work head, this is the assembly work head station, and this is the work carrier. इकडून जो पार्ट येईल तो इथे काहीतरी त्याच्यावर ऑपरेशन केलं जाईल, आणि या हॉपरमध्ये असे नंबर ऑफ पार्ट्स असतील, अँड वन पार्ट ॲट अ टाइम विल come through this track and it will be provided at this assembly workstation. So here you can see for what different applications such arrangement can be used. That is given, that is alarm clocks, audio tape cassettes, ball bearings, ballpoint pens, cigarette lighters, computer diskettes, uh, electrical plugs and sockets, fuel injectors, gearboxes, light bulbs, locks, mechanical pens and pencils, printed circuit board assemblies, pumps for household appliances, small electric motors, spark plugs, videotape cassettes, wrist watches. So number of applications are there. So we can use this automated storage and retrieval system for reducing the processing time and increase the production rate. So here we'll stop for this session, and rest will continue in the next